SSH into it, and drop the file in with the password secured. They put the data up there, and then I can turn the container off and drop it, and it's no longer available. And this is all achieved by a simple Docker run command. I run it as a daemon and as a privileged container. I open up port 22, all right, and that's the name of the actual container that's available. We start it up, give the customer access, bring it down, kill it, all right, it goes away. And because I have this as a Docker file, I can quickly recreate the environment by simply doing a Docker build, as Aaron pointed out. So these are some of the examples of, I mean, if you look at it, you're like, well, wait a second, there's a lot of bash commands just right embedded into a Docker file. Yeah, right? These run commands are basically bash. So we create a Docker file, we save it off, we can create the image and recreate that, make that available anytime we want connectivity with the customer. It's just a simple, kicking the tires, getting used to it example. What I wanted to go through right now is the 3 projects we have underway, or 3 activities underway where we're using Docker inside of our group. I'm going to give you a little bit of background or introduction to each project, but that's really not important. The question is, how do we actually go off and use Docker? Now, I will emphasize that in these 2 projects here, the last 2, in a month span since we were supposed to have this session maybe a month ago, the evolution from the charts here, I mean, the experience we're having about continually automating and improving our build automation with Docker it's exponential. So some of this is outdated, but I think that the emphasis here is continue going through and using Docker to improve your workflow. So one example is we have this internal tool that one of our teammates wrote. It's just a wiki, but it's a collaborative wiki. Multiple people can access it and interact with it at the same time. Well, like any other wiki, it has a database. Right? So, we stood this up for several of our teams, and we're all using it internally to collaborate. The wiki's not necessarily important here. What's important is, once we have this up, how do we make sure we have a persistent state of the wiki and we can actually back it up and restore it, right? So, what do we do? I'll have you focus first on the bottom of the screen. There's essentially this notion of being able to, when a container is running, you can save the container, all right? So think about it as you're taking a snapshot of the container, and it's saved as a tarball. Now, once I have it as a tarball, I can go and recover from that tarball at any time I want, or I can send that tarball to another environment and do a load in another Docker environment. Somebody asked that question before, and I can load it up, and now that container, the state that it was in, that top corner snapshot, is up and reproduced. So now I have portability of the containers. So these are this flow here is very simple, right? I'm going to load a tarball, right, that I have somewhere on my system, into my Docker environment, and then I can type Docker images, and it loads it as a registered image in that environment. Once I have it imaged, I can tag it and give it a name, all right? And then I can remove any prior images that in this case, I want to make sure I'm always replacing to the same name, right? So I'm loading in and removing the old image. And then back to the basics. Docker run as a daemon. Now, here I'm using the same internal port with my Docker build as my external exposed port, but I can change this, right? This comes in handy. This is your internal port in the Docker environment, but it can be exposed at any port you want. And you can name it, and then you go off and you run the script for that container. So, using this process, what we do is essentially we keep a 24-hour a snapshot of all the tarballs. Nothing, no rocket sciences here, but we create a cron job. We kick off several of these scripts.
That's
yeah.
the persistent state of a container, not the runtime state.
So the database is all within the container, right? So we're just taking, instead of backing up just the database, we're taking a snapshot of the entire container. All the code, all the data within the container, right? So think of the container as the data, the code, everything with the configuration, and we're snapshotting the entire thing.
The memory state of any process that's running.
Yep. Yep. Sorry, question about?
That was my question. Is that you're capturing a memory snapshot as well by doing that?
You're capturing the state of the container at that point. The entire, so everything.
You're not getting that.
But you can, if you bring it back up,
Anything that's been written to files.
yeah, and anything that, so, go ahead.
Well, no, so I'm just curious, so let's say I'm running NODB database, right? There's dirty pages in memory, am I capturing those? No, am I capturing a
No,
memory snapshot? I'm
You
only
kept capturing whatever's been written to disk.
That's been flushed to disk.
Yeah. Yeah.
No, if you got mounted file systems outside the container, they'd be stored on the host, not in the container.
And a snapshot will not capture,
No.
don't ship.
No.
Now, when we first wrote this, and we have, this is running, in this case, this is running on an older server with an older version of Docker that we hadn't updated, and there was a bug that we had found. So we wrote some Python script to actually do a commit. I don't think you need to do this anymore. You can just do the Docker save, which is actually down here. The actual Docker commit is down here. It's executing, and then the next step is what we do is we create these, this templated script where we set up for each project what we want, where our backup sources are, in basic bash. We do a Docker commit. We commit the running container. We take a snapshot of it. We save that. Save it to a tarball, and then we remove the original. We remove the temporary container that we snapshotted. And then we just copy that off in two places, one on a mounted drive, one on a local drive, so we have redundancy to back up. And it's just, this is ad hoc, your own kind of DevOps setup here for doing a backup. All right, and we also back up all of our tools with the same way. That kind of makes sense? Question?
Well, I know you're still playing with it, but why would that be better than just having almost a stateless wiki and then having a central database where they could always just attach that back to that?
It comes down to ad hoc, right? This tool is just, we needed something, boom, you're talking about teams of 2, 3, 4 people, right? We don't, we just needed something to get going, right? It's available tools, just good enough, right? That's what it comes down to. Is this, you can use that for production or something? No, this is just good enough, right? I don't need to be calling my IBM IT staff and setting up with an environment. This is the point. It's just good enough, just in time, low barrier of entry. Okay. Okay, so we have this other project. This is a data science project that we're building. Anybody familiar with the IPython notebook? Okay, so we're basically building a data science workbench around the IPython notebook. Now, in building this, if you're familiar with the IPython notebook, you can set up a cluster for parallelism, parallel processing, and there's a number of tasks here to set this up on the cloud. It's not simple to set this up on the cloud. So what we've done is we've essentially set up a GitLab node on the cloud. We have a storage area, and of course we have our potential targets where we can install this. We're installing everything right now on software, but we can go to any of the other targets. So going through this workflow, we have to pull code from Git. We build our containers using our Docker files. We publish them up to the containers up to our images, and this is all up to the build server. And then from there, we can actually SCP the containers over to the target environment where then they can be loaded, right? So think about it. Here you have a build or provisioning server where you're doing all your work, and then you're copying the containers, you're distributing the binaries over, which if you think about it, what Aaron was talking about with Docker Hub, you're doing, they're hosting those binaries for you.
Did anyone drive a BMW motorcycle here?
Did you park it on the exit, sir, the stairs?
Yeah, it's
Okay.
to the side.
You need to move it or they're gonna tow it,
Okay.
okay? Just wanted to save you on the charges. Sorry.
Thank you. No, thank you.
Dan.
So, not to go through all those gory details, but what Aaron pointed out was before is that there's this notion of a Docker file. But what we did was we took our build process, right? Essentially, a series of make files. And how do we enhance our make files with these Docker files? So do a full make build, what we're really doing is we're actually going to each subcomponent of our project, creating the base image for each of those subcomponents. So we're breaking down the project into subcomponents, which are containers, right? And then for to build each of these base containers, we need to generate a base Docker file dynamically. We have some reusable Docker snippets, if you wish, how to get Flask and Java and build all these other subcomponents that are reusable. And then we have, for each component, a base Docker file that is specific to that component. And we have some code to go run into our makefile to generate this dynamically, and then we do a Docker build off that. And so that is, elaborate set of makefiles, but we get to the point where we're just doing commands. Under the covers is a lot of Docker builds, Docker runs, and you'll see that going forward. All right. Once we're all done with building everything up, we do a make archive where we actually archive up, do a saving of all of the base components into a tarball, and then we compress that tarball, and of course, the next step is to push it. That's where we go from our build server over to the target image, where we're just sending over the tarball, which has in it now all the containers. So if I unzip that, all I need to do then is load all those containers in my Docker environment is now provisioned. Right? So I'm very quickly provisioning a targeted system that just has a Docker environment there, and I'm sending all the containers up to it. Make sense? So, here's some of the kind of undercover details, but type in make development workbench. The key here is in our run commands, we're running. In this case, we're building a specific the notebook server. We're naming it, and once this is built, we do this command, and we'll go through each one of the containers, building each container of for the base components. Sure, go ahead.
Are those small containers reusable? Why
Yes.
just don't put one big container?
Well, but see, now you're breaking down the beauty of Docker by doing containerization, right? You're separating out these subcomponents of work. If I package everything together, if one thing changed, if one component changed, I'd have to change the entire one. But here, I just have to change the one that changed, right? Without impacting everything else. It's about efficiency of your process.
It's still compatible with Docker.
But you know what? It all comes down to, back to an earlier question, depending on your application, right? Each project need is different. So for this project, that level of granularity was important, where for others it may not be, right? Those are application design decisions, right? So here's an example I will point out, more elaborate Docker run here, where I have multiple ports to be opened up to this container. So it needs port 88 for the web server. It needs to have a SSH port open, but we actually expose it as 2222. So that's the external port, that's the internal Docker interface, all right? We're mounting an external volume here, and we're giving it a tag. So when you actually, this is a command here, Docker PS, where you can actually see all the containers that are running. So now you can see here that, look at this bottom one, we have the notebook server. It's named Supervisor D. It was instantiated 5 days ago, and here's the port on localhost. It's running on 2022 on this internal port. This was 88, and that's the name of the container if I want to reference it. Okay. So when you're working in Docker, if you guys have already played with this, Docker PS, Docker PS-A are common commands. Questions on that? No? Okay, so we have another project called Mobile Identity. This is an interesting project where we're building a set of cloud services to deal with the I'll just call it the future of identity. We all carry different forms of identity, driver licenses, and identity cards of all types, whether it's fishing, hunting, library cards, student IDs, and so forth. But what we're doing here is that we have a central server that is acting as a conduit for managing identities on behalf of many different issuers. Each one of these entities, if you wish, are clusters of components in our project. And each one of those components, we've basically developed them as containers, Docker containers, and able to create the environment. Right now in our test environment, for example, we're able to quickly kick off a number of different issuer servers, all with the same containers running, and they all talking to the central server. To give you a better picture of that, and I think Aaron had pointed out that some people are using System D to do some process control. We're actually, for this work here, we're using etcd. etcd allows us to do key values management, so basically configuration management across the cluster. So here I have a single node cluster, all right, a cluster of multiple Docker containers. So they're all running as independent nodes within the virtual machine, but by simply having my base minimum Ubuntu image with Docker and etcd installed, I have the ability to manage and configure these containers in that one environment. Now, as a single node, that becomes my central server, but it's got a number of different separate subcomponents running as containers. And in this case, we're actually, our data is being stored on a RDS system up on Amazon. Was there a question over there? No? Okay. Oh, sorry.
Are you using etcd for service discovery or just configuration?
So, great. Back to remember that continued evolution. We're not at service discovery yet because with some of our components we have to rip open the code to, we're using some black box code that we don't want to open up yet. But what we are using is to do for configuration. So when the system comes up, we're using etcd to have basically the master configuration for this node, and then all of these components will have pull their values from it, right?
All your container is running as a foreground process, right?
No, background, daemon, dash D. You'll see on a lot of our runs it's a dash D, so background. So here's, this is kind of simple to make a series of make files, and targets, but make all simple, clean. But when we get into some of these, so let's just take the AMS ones, account management component, where we're actually just going off and doing a build, and here we're building our config file. Now, to the question, this was how we were doing configuration. We were using special code to build a config file. Now we're using etcd. So in a month, we've just increased our change starter processing. So a Docker build, I don't know if Aaron pointed this out, but I think he did. The Docker build is what you actually take that Docker file and it runs through the Docker file commands and generates the image, right? So that's how the image, once the image is created, then you do a Docker run on that image and that creates the container that's running, all right? So during these make files, what we're doing is we're creating the base images for each one of these components. As I mentioned, this is how we were doing some bash scripts to do create a configuration file, but we've now moved this over to etcd because evolve and improve, right? Continue DevOps improvement. Okay, so we pointed out some examples to build the components, and then once you build it, then you can now run it. Now here's the example, right? Here's the internal port. We assign it to an external port. And here's the actual code. When the container gets kicked off, that's the actual code that will be instantiated or invoked to start the container, right? And that's your own code. It's dependent on your application. Same things, just a couple other components, and that's all I have. Questions? So the point I was trying to make here is that how Docker can be actually used in application development, and that whole process of improving your DevOps is an evolving process, and I think Docker is a very key enabling tool for continuous improvement in that process. Questions? Yes?
Just an IT question. If you send the container to someone who wants to deploy it on premises, the third party,
Yep.
how difficult for them?
Perfect. So they don't have they don't have a cloud. They don't have an on-premise cloud. Maybe they don't even have VMware, right? Maybe they just have a a very basic, bare metal, Red Hat box. All we have to do is install Docker on the Red Hat box, take the container, put it on, Docker load image, Docker run.
Still you need to configure.
Well, but,
Right, the port.
but now you need to configure Docker on that environment, but as Dan's gonna point out in a minute, it's not Survivor, right? There's provision scripts for that. As I mentioned, up on soft layer, we have provision scripts when you do the launch, you order your VM, you can actually have a script automatically provision Docker already for you. And if you're interested in that, I can point it to you. Yes, sir.
With Docker, do you find that you use less instances of VM than before?
Yes.
By how much?
Well, that depends on your project, right? I mean, it all depends, like here, we had one VM where I had multiple nodes, container nodes inside that VM. That's an application design decision that we have within our project, right? It all depends on the project, right? I think, don't think of it, I guess you may come up with some pros or cons for relative to VM reduction, but I think the more important point is about the flexibility for distribution, right? I build it once, and you've all heard this before, right? Build once, run anywhere. But build it once, deploy it, and there's a lot of power to that. Especially for an application development team where, one day I could be, my account could be available to me on Amazon or on SoftLayer, or maybe I have, my customer needs it on it, like your question, he needs it on a specific environment. I don't have to worry much about their environment. All I need to say is just install Docker for me. Right? If I can get a Docker daemon installed for me, I can run my container. That reduces a lot of application development headache. Right? Let's focus on the application to be developed and not the operations. Right? Other questions? Yeah.
I'm curious about when you were running the multiple